In this video, I'm going to introduce you to the definition of the derivative. I'm going to explain where it comes from and why it works, the different notations. We're going to be using the limit of the difference quotient. And all of that and everything on the screen looks very scary, but it's not. Basically, we're working off the idea of slope. So we're going to start this by looking at an example. If we were to demonstrate the height of an object as it falls from 100 feet, it's given by the equation h of t, the height of any given time, is given by 100 minus 16t squared. So we might be wondering, what's the average rate of change, or basically the slope between points A and D? So we're simply looking at m equals y1 minus y2 over x1 minus x2, an algebra concept. And we can go ahead and calculate that quite simply. So we would have 100 minus 0 over 0 minus 2.5. And when we simplify that, we're going to get negative 40. And all of these would be in feet per second. Okay, between points B and D, we can do the same thing. And in that case, we're going to have 84 minus 0 over 1 minus 2.5. And when we simplify that and divide, we end up getting negative 56 feet per second. Shouldn't be any surprise, because as we're getting closer to Earth, the average rate of change is going to increase in terms of its speed. Its velocity is becoming more negative, but the speed itself is increasing. The negative just denotes that we're going towards the Earth. And if we go to point C, from C to D, we would simply have 36 minus 0 over 2 minus 2.5, which would give us an answer of negative 72 feet per second, which makes complete sense. We're getting closer and closer, so we are speeding up if we look at the absolute values. So the question is, what happens at point D, at 2.5, or just before we reach it? Well, we no longer have the slope between 2 points, which we call the secant line. We're looking for the instantaneous rate of change. So in order to do that, we have to introduce the concept of limits. So we were going between 2 points. So we were essentially looking at some value at x minus our value at 2.5 over the difference between the two, which was x minus 2.5. So we were getting closer and closer. So that means we're just going to take the limit as we approach 2.5. And that's going to give us the instantaneous rate of change at 2.5. And we're going to look at notation about that in a minute. So let's go ahead and do that. So f of x would simply be 100 minus 16x squared. F of 2.5 was 0 all over x minus 2.5. And we're going to take the limit as x approaches 2.5. And if we go ahead and substitute 2.5, we're going to end up with 0 over 0, which, as you know from limits, that's indeterminate. So we're going to have to do something. And that do something is going to be simplify, factor, and cancel. So let's go ahead and look at the fraction. The 10 minus 16x squared can be factored to 10 minus 4x, and that was 100 minus 16x squared, times 10 plus 4x, and all of that's over x minus 2.5. So we don't see anything glaring at us. So let's go ahead and rewrite that to be negative 4x plus 10. And see if that looks nicer, times 10 plus 4x. Now, let's just stick with that. We're looking for x minus 2.5, so we can kind of see that hidden here if we factor out the negative 4. So if I do that, we have negative 4 times x minus 2.5, there it is, times 10 plus 4x, all over x minus 2.5. Again, this is just the algebra, which sometimes can be a little messy. This isn't too bad. So the x minus 2.5 is going to cancel. That means we can substitute the 2.5 in to get our final answer. And if we do that, this is going to bring us to negative 4 times 10 plus 4 times 2.5 all over 1. So this basically is going to equal negative 80, and that's going to be feet per second, which makes complete sense in terms of what we saw in terms of speeding up when we look at the absolute value. All right, so in general, what are we doing? Well, we're really going from one point to another. That's a secant line, and we're getting closer and closer. So that was the idea of taking the limit. So what started off as m equals y1 minus y2 over x1 minus x2 became us looking at the average rate of change. And for this problem, we were looking at f of x minus the value at 2.5, but we can do this for any point, f of a over x minus a. So that's another way to look at it. But we took the limit as we approached a. So our definition of the derivative, which means the slope at a point, as x approaches a, of f of x minus f of a over x minus a. Now this is a lot to say at once, so we come up with some different notations. And another way to write this is just f prime of a. So that little apostrophe is just pronounced prime. That means it's our first derivative, means the slope at a. That's what all of this means. So this means the slope at x equals a. Now there are other ways to write this. Another way to write this is rather than looking at x minus a, we just call that distance that we're closing in, that change in x, h. So that means we're now going to take the limit as that distance approaches 0. And then our point would be f of a plus the distance out to h. That's our other point that we would be at. So let's say at 100, at 0, 100 here. And then we're subtracting the value at that point all over h. This is also the slope at x equals a, or f prime of a, or the derivative at a. And again, there is another notation besides the prime. Some people will write it as dy dx, which looks like the change in y over the change in x. A lot of people like this. And we put a little line here for evaluated at x equals a. This also means the slope at a. So all of this looks really scary, but really what we're doing is we're just taking the slope between the function and a point and taking the limit as that distance approaches 0. All right, so let's go ahead and take a look at an example and see if we can understand it a little bit better. So we have some function 2 over x minus 4, which we have a graph of it here. First question just says average rate of change. And whenever you see this, realize it's an algebra question. We're just finding the slope. So to find that slope, let's go ahead and find out what is f of 5. F of 5 is 2 over 5 minus 4, which is just 2 over 1 or 2. F of 10 is 2 over 10 minus 4, which is 2 over 6 or 1/3. So our slope is simply 2 minus 1/3 over 5 minus 10. So that gives us 1 2/3 over negative 5, which if we simplify this, we'd have 5/3 over negative 5, which simply becomes negative 1/3. So that's our average rate of change, which makes a lot of sense because again, we're looking at the point 5,2 and the point 10, 1/3. All right. So now it wants to know what is the slope of curve at 5. So that means we are looking at that tangent line. That tangent line has the same slope. What does that mean we're going to do? Well, let's write our definition down. We're taking the limit as we approach 5 of f of x minus f of 5 over x minus 5. Okay, so that's our first step. That's using this definition, and we'll use the other one as well. So this tells us, remember, this tells us f prime of 5, the slope at 5. So if we do that, f of x, as you recall, is 2 over x minus 4. So I'll show it to you, 2 over x minus 4. Minus f of 5 is simply 2 all over x minus 5. All right, I should use arrow there because we still need to take the limit. That was just our substitution. So we know when we substitute in 5, we are going to end up with indeterminate. So we're right away going to use our limit strategies and we're going to combine the fractions and simplify. So in doing that, that's going to bring us to 2 over x minus 4. We'll get a common denominator. Minus 2x minus 4 over x minus 4 all over x minus 5. And if we continue with that, that means we're going to have 2 minus 2x minus 4 all over x minus 4 over x minus 5. Again, it's just algebra skills right here. And that's going to bring us to 2 minus 2x plus 8 over x minus 4, again, all over x minus 5. We can simplify this 2 and that 8, that's going to bring us to 10. So we're going to have 10 minus 2x. Let's go ahead and factor that right away. Or, you know what, let's rewrite it as 2x plus 10 over x minus 4 over x minus 5. And remember, we're not forgetting about this limit as x approaches 5. We're just doing our algebra. So this is going to bring us to factoring out that negative 2, let's say, which is going to be x minus 5 over x minus 4. And we're dividing by x minus 5, so let's just go ahead and multiply by 1 over x minus 5. All right, and there it is. We can cancel that x minus 5. So now we're ready. We're left with negative 2 over x minus 4. So we are going to take the limit as x approaches 5 of that negative 2 over x minus 4, which means we can just substitute in that 5. So we get negative 2 over 5 minus 4, which is negative 2 over 1, or simply negative 2. Now let's go back at the graph and see if that makes sense. If we look at this graph, if I did a better job drawing that tangent line, we would see that that slope looks like, down 2 over 1. So it does make a lot of sense. So we were able to find the slope of the curve at that point. Another way we can write that is the fact that f prime of 5, or the derivative at 5, is equal to negative 2. Again, just means the slope of the curve at 5. Now, if they ask you for the tangent line, whenever you see the equation of the line tangent, don't let that scare you. There is a way they write that. A lot of times they'll write y minus f of a, which is equal to f prime of a times x minus a. Again, that looks scary, but if you think back to algebra 1, it's just point slope. Y minus y1 equals m, our slope, times x minus x1. So if we go ahead and think of it that way, we have y minus, our y value at that point was 2. We found our slope earlier was negative 2, and our x value is 5. So that's our equation. I always like to write it in function form, so y equals. So we'd have y equals negative 2 times x minus 5 plus 2. So again, whenever you see the phrase equation of the line tangent, you're just thinking point slope. It's fill in the blank, really, for what your values are. Let's go ahead and take a look at one more problem. This is a question you might be given, which looks scary because it's just showing you notations. There's really no work to do here. They're giving you f of 2 equals negative 3. So what that means is when x equals 2, y equals negative 3. Then they say, and f prime of 2, which means the slope at 2, so the slope is equal to 4/5, only at x equals 2. They want the equation of the line tangent. So again, that's going to be y. I'm going to write it in function form. Y equals, normally we would have this. I like to see this again as fill in the blank. So this is the only thing we're filling in. So y will equal our slope, which is 4/5 times x minus our x value at 2, plus our y value, which in this case is negative 3. So really it's a fairly simple question. So again, there are many different ways we can talk about slope, and it's interchangeable with the slope at a point is the derivative at a point. And we can even go one step further and find a slope finding formula for the equation where we don't have to keep doing this if they ask us multiple questions, which you will see in the next video if you take a look at that, where we'll look at finding the derivative function for any equation, again, using the limit of the difference quotients. Following that, you will see all the different shortcuts there are. You'll like those a lot better. I hope that helps.